Welcome back, guys. Today I'll be doing January 2021 question number 1 and 2D. For question 1A, using a calculator otherwise, calculate the exact value of 1 and 4 over 7 plus 2 over 3 minus 1 and 5 over 6. Now, what I like to do here, we're going to go ahead and rewrite this as an improper fraction. So if I'm going to write this as an improper fraction, I'm going to multiply 7 times 1, that's 7, and then I add 4, so that gives me 11. So I have 11 over 7 plus 2 over 3. Changing this as an improper fraction, we are going to have 6 times 1, that gives me 6, plus my 5, and that gives me 11. So I have minus 11 over 6. Now, when finding the LCM, we find the lowest common multiple for 7, 3, and 6, and this will be 42. Now, then we say 7 into 42, that goes 6 times, so we multiply 11 times 6, that gives me 66, plus 3 into 42 goes 14 times, so we're going to say 14 times 2, that's 28. Rewrite my minus sign, then 6 into 42, that goes 7 times. So I'm going to multiply 7 times 11, that's 77. Now, calculating this, 66 plus 28 minus 77, that will give me 17 over 42. And that's right in the form. Right, for the next question, we're asked to write the value of the cube root of 27 all over 9 squared as a fraction in its lowest form. So we're going to find the cube root of 27 all over 9 squared. Now, cube root can be found on your calculator. So if you're unaware that the cube root of 27 is 3, let me explain how do you find the cube root on your calculator. So let us look at a few calculators. I have the different brands. There are more brands, but you will get the general idea. So if you need to find the cube root, so to get cube root on your calculator, for this first calculator, you press shift. Here is the shift button. Then the square root. If you realize the cube root is on the calculator background itself. So that's how you get cube root on calculators like this. Other calculators, you have shift. Then we enter the x cube. So x cube, you'll have this is what gives you the cube root, along with shift, same x cube. So most calculators, they have the same thing. So we have shift, and then you'd have entered this root button. That's what gives you cube root. So cube root of 27, that's 3. 9 square means 9 times 9. So 9 nines, that's 81. So we have 3 over 81. Now you could also enter 9 square in your calculator. This is so for square you can enter, this is the button that gives you square. So x square is rather explanatory. This is the button that gives you power square. So each calculator will have the x square on it. That's how you get the square. But if you have other powers, you can use this function or xy that gives you power, or I like to call this arrowhead, or even this function where you have x and a square being the power. That's how you represent, say for example, you have 9 to the 5th. So 9 nines, that's 81. Now, suppose you didn't want to simplify from here, then you could have simplified here to say 3 into 1 goes 3 times 3 into 9 goes 3. But if you don't want to cancel from here, then it's okay to say 9 nines, which is 9 squares, 81. Then we reduce, 3 can go into 81, 27 times, and 3 into 3 goes 1 time. So the answer is just 1 over 27. That's it. That's in its lowest form. The thickness of one sheet of cardboard is given by 485 times 10 to the minus 2 millimeters. A construction worker uses 75 sheets of the cardboard stacked together. So in other words, one sheet, this is the thickness. So we have 75 sheets being stacked together to insulate a wall. They're asking us to show that the exact thickness of the insulation is 363.75 millimeters. Now, here we have one sheet. One sheet has a thickness of 485 times 10 to the minus 2 millimeters. So all we want to know is what's the thickness if I have 75 sheets? So in other words, I would have to add this figure 75 times to find out the total. So rather than doing that, I could just multiply. So multiplying this figure by 75, I'll be able to find the total thickness. So multiplying, this is what we are going to do. We're going to have 485 times 10 to the minus 2 because this represents the thickness of one sheet. So if I know for 1, I can find out for 75. Just multiply by 75 because it's 75. No, I would multiply 75 times 485. Leave the 10 to the minus 2 for last. So multiplying 485 by 10 to the minus 2, and what we'll get is 36,375 times 10 to the negative 2 millimeters. So this is a thickness, but it's a proof. When we have a proof, we have to show, meaning we need this exact value. So to get this exact value, now when we have negative exponential, what are we going to do? I have my 36,375 and the minus 2. I'll put a decimal point here and it's telling me I should move my decimal point 2 places to the left. So I move it 1, 2. So therefore I have 363.75 millimeters. And that's it. So remember, they gave us the thickness for 1 and they want the thickness for if I have 75. So if we have 75 sheets, all we have to do is multiply 485 times 75. That will give me 36,375 times 10 to the minus 2. Now times 10 to the minus 2 means that I will move my decimal point because by right there's a decimal point here, but we don't write it if we don't have any number behind the decimal point. So we're going to move it 2 places to the left. So it becomes 363.75 millimeters. And that's it. Now, the next question is asking us to write the thickness of the insulation correct to 2 significant figures. Now, remember we found out that the thickness is 363.75 millimeters. So what we're going to do is rewrite this to 2 significant figures. When we're looking at significant figures, this is considered to be the first significant figure, then this will be the second significant figure, this will be the third significant figure, this will be the fourth, and here I have the fifth. If we have zeros in between, it does have a value, but if we have a zero, say for example 0.75 alone, or suppose we had 0.035, this doesn't have a value, so this will be our first significant figure, which will be 3, and this will be our second. So once you have zeros in front, it has no significance. But if we had 10.075, then this would be our first significant figure, or second, third, fourth, and fifth. So once we have zeros in between the number, it holds a value, but before the number, it doesn't hold a value. So for this example that we have here, we have 363.75. And what we're going to do is round it out to two significant figures. So our focus is on 6. What is behind the 6 tells us whether we should round up or down. Because this is a 3, it means that we will not round up. So therefore, to two significant figure, we're going to have 306. This is going to be just 6 because this number that is 3 that falls behind the 6, because it's not 5 or greater, we will not round up. So if this was a 5 or a 7, then we would have rounded up the 6 to become a 7. So since it's a 3, we will not round up, we'll leave the 6 as it is, and we'll add a 0 as a placeholder just to not change the value, because remember, this is 300, this is in the hundreds, tens, and ones. If we don't write the 0, we have changed the entire value. It's no longer 300, it is now 36. We don't want to change the value, so therefore it is 360, where we put 0 as placeholder. So the two significant figure is 360 millimeters. One decimal place. So the next word asks us to change it to one decimal place. Remember, we're doing the same question, 363.75 millimeter. So for this, decimal place means behind the decimal point. So this is my first decimal place, which is 7. So that means I will look at the number that's behind it. It determines whether I round up or I leave it as it is. So since behind the 7 is a 5, I will round up, so that means rounding it off will be 363.8. So behind the 7 is a 5. So therefore, I am going to go ahead and add a 1 to the 7. So the answer is 363.8 millimeters. We're also asked to write it in standard form. The general form for standard form is a times 10 to the n. Now, a should be greater than or equal to 1, but less than 10. So you should never pass 10, but it can be 1 or greater. Now, the number that we have is 363.75 millimeters, and we're asked to write it in standard form. So if we want it to be basically from 1 and not passing 10, then it means I have to move the decimal point one place. If I move it one place, it becomes 36. That's not between 1 and 10. So I move it another place, and if you realize here, it becomes 3.6375, and this number is between 1 and 10. Let me correct, this is millimeter, not meter. So therefore, as standard form, I will have times 10. Now, because we have moved the decimal point 2 places to the left, I am going to go ahead and have times positive 2. So here, we're going to have, since we moved the decimal point 2 places to the left, then I'm going to have times 10 to the 2. So if I've moved it 2 places or 5 places to the left, then your standard form will have times 10 to the 5. So the answer for this is 3.6375 times 10 to the 2, or if we want to round it off to 2 decimal place, then we can do that activity. This is the second decimal place, or this is the first. The 6 is the first, this is the second. So behind the 3 is a 7. So what will we have? We'll have 3.64, because we have to round up, times 10 to the 2. If we wanted to do it to 3 decimal place, then we'll have it at 7, but behind the 7 is a 5, so I will have to round up. So this will be 3.638 times 10 to the 2. So just a reminder, for this question, standard form, this is a general form. So we have 363.75, and I would like to write this in standard form. This should be a number between 1 and 10, basically from 1 and less than 10. So in other words, we have to move the decimal point until it satisfies this criteria. So we move it 1 place, it's still not between 1 and 10. 2 places, so now we have 3.6375. This is now satisfying the condition. So satisfying this condition, we can now see that the answer is 3.6375, and it's times 10 to the 2 because we have moved the decimal point 2 places to the left. Now the next activity we have here, it's an exchange rate question. Marco is on vacation in the Caribbean. He changes 4,500 Mexican pesos to Eastern Caribbean dollars. He received 630 EC. Now complete the statement below about the exchange rate. We want to know how much Mexican pesos should we have to buy 1 ECD, which is Eastern Caribbean dollars. So look at it this way. I have 4,500 Mexican pesos, and it gives me 630 Eastern Caribbean dollars. So you now want to know what is really the cost to buy 1 Eastern Caribbean dollars. That's what you want to know. So what we can do, we can cross multiply. So we say 4,500 times 1, that gives me 4,500 is equal to x times 630, that gives me 630x. Then I divide both sides by 630. This cancels, so x is equal to 7.1428 Mexican pesos. Now, if they wanted to 2 decimal place or 3 decimal place, we could go ahead and do that. So if we want it into 2 decimal place, we would say 2 decimal place. This is a 4, so we'll have 7.14 Mexican pesos. If they want it in 3 decimal place, then we'd have to look at the 2, and behind the 2 is an 8, so therefore it'd be 7.143 Mexican pesos. So in other words, for this question, we basically have 4,500 Mexican pesos. It gave us 630. The reality is we want to know how much Mexican pesos will give me 1 Eastern Caribbean dollar. So we cross multiply 4,500 times 1, that gives me 4,500, and then x times 630, that gives me 630 times x. Then I divide both sides by 630 to give me the value for 1 Mexican dollars. Now the final question is question 2D. Here we're given that the distance needed to stop a car, D, varies directly as the square of the speed S at which it is traveling. A car traveling at a speed 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop the car traveling at 80 kilometers per hour? Now, they say that the distance needed is directly proportional to the square of the speed. So the distance is directly proportional to the square of the speed. So we know that we can rewrite this as an equation where D equals ks squared, where k represents a constant. Now we're given that the distance is 40 meters. Reality is we could work with the 40 meters, but since we have kilometers per hour, I'm going to go in more detail. We can change 40 meters to kilometers by dividing it by 1,000. So dividing it by 1,000, we're going to get 0.04 kilometers. So that's what it is. So the distance that we have, so it's saying that a car traveling at a speed of 70 kilometers per hour requires a distance of, it's the same thing as 0.04 kilometers. The only reason why I changed it to kilometers because this is already in kilometers. So that's why I did it. Now, here we need to always find K. So to find K, this is what we're going to do. We are going to substitute the information that we have. We're going to substitute. So we have the distance is 0.04 kilometers. We're trying to find K, the constant, and we're given the speed. So we have a speed of 70 kilometers per hour requires a distance of 40 meters. So I'm going to replace here to be 70 kilometers per hour square. Now squaring this, it means what we're going to have is 0.04 kilometers is equal to, now we're going to square the 70. So 70 times 70, that's 4,900. So I'm going to have 4,900, and squaring means I square the unit. So I have kilometers square per hour square. See, we have squared it. So everything is being squared. So now we divide both sides by 4,900. And doing this in CSEC, it shows that you understand. So this is how you're getting the straight A profile. So that's why I'm showing this detail. because in order for you to get a straight A profile, you have to show that you clearly understand everything and your reasoning ability is present. So we divide both sides by 4,900. Now this cancels, right? So what happened here, we're going to have some cancellation. So first you work out 0.04. So we have 0.04 divided by 4,900. Now dividing this, you should be getting 0.000. Well, I have 5 zeros. 81633. Now with the kilometers square, this is what's going to happen. So if you realize, we have kilometer over kilometer per hour square. So for this, when we have per hour square, it really means kilometer over. Now this will be kilometer square over the hour square. So this becomes a fraction. When you have a per hour, it means it's division. Now reality is, when you have a fraction in the denominator, we flip it. So by right, this is kilometer times, we flip it, so it becomes 8 square over kilometer square. That's what this is. So this cancels one of the kilometers. So what we have is 8 square per kilometer. So it's now 8 square per kilometer. So I repeat, this is just for us to work towards getting our straight A profile. So we have kilometers, and then this is kilometer square over, this will be over 8 square. That's what per means. So it's in the denominator. When you have a fraction in the denominator, we flip it. So flipping it, what happened? We can cancel one of the kilometers. So by right, we have 8 square over the kilometer. So that's why I have 8 square per kilometer. So it means the constant will be 8 square per kilometer. That's what we have. Now to continue with this question, because we're not finished. So now we're going to calculate the distance. Remember, this represents our constant k. So substituting this information, the distance is equal to, remember, we want the distance required to stop a car traveling at 80 kilometers per hour. So I will have the 0, k is 0.1234, and then I have 81633, and the unit is hours square per kilometer times s square, where s represents the speed. So the speed that we have here is 80 kilometers per hour square. Now squaring this, we have d is equal to, now 0.12345 81633, and we have hours square per kilometers. So 80 square will give us 6,440, and we're multiplying this. So multiplying 6,440 multiplied by 0.00000, so it's 508163, that will give us 0.50522, and I'm gonna leave it as 45. Not gonna do it to all decimal place. Now this is in kilometers. How is it that I know that it's kilometers? Let's look at that part. So for here we have the following units. We have the first part being hours square per kilometer. That's all we have. Multiply by kilometers square per hours square. Remember I said this is a fraction, so I can have this as hours square over kilometer times kilometers square over hours square. So right here, these would cancel, right? And one of the kilometers will cancel. So here we have this being kilometers. But since they gave us as meter, we can quickly multiply this by 1,000 and we will get the answer in meters, where I move the decimal place 1, 2, 3 places to the right. So the answer is 52.245 meters. Thanks for watching, guys. Don't forget to like and subscribe to my channel.